So when we're talking about the law of definite proportions, this is kind of a no-brainer. This is a characteristic of compounds. Regardless of the amount, a compound is always composed of the same elements in the same proportion by mass. Okay? That's it. In other words, H2O is always H2O is always H2O. If it's not H2O, it's not water. Does that make sense? And hydrogen and oxygen are always going to be present in water with the same proportions. Let me explain this to you in a song. Just kidding. I hope that got your attention. Let me explain this to you with some math. Here is the card for hydrogen on the periodic table. Hydrogen has one proton, and we're going to talk about this more later, and has a mass of 1 gram per mole. Oxygen has 8 protons and has a mass of 16 grams per mole. These are grams down here, grams per mole. Okay, the formula for water is H2O. So in other words, 1 plus 1 plus 16. So the total weight of water is 18 grams. And out of that 18, 2 of the grams are hydrogen, and 16 of the grams are oxygen. Does that make sense? So H2O has a molar mass of 18. 2/18 of it's hydrogen, and 16/18 of it's oxygen every time. So if you found a mystery liquid on another planet, and you used electrolysis to separate the compounds, and it was 2/18 hydrogen and 16/18 oxygen, then it's water. Period. It's nothing else. Does that make sense? Now that's regular chemistry, and we stop there. But we're in honors chemistry, so we're going to be talking about something called the law of definite proportions. All right? The law, excuse me, I already talked about the law of definite proportions. We're going to talk about the law of multiple proportions. Pretend this is working perfectly. There. The law of multiple proportions. Now, you're not going to write all the steps down. You can make a short note up here at the top, but let's talk about it. When different compounds are formed from a combination of the same elements, different masses of one element combined with the same relative mass of the other element in a ratio of small whole numbers. And I know that sounds confusing. Make yourself a short note about it however you can. So, in the example from that slide, we were talking about carbon monoxide, and we were talking about carbon dioxide. And we were talking about applying the law of multiple proportions to these two different compounds, or these two different molecules, all right? Carbon is number 6 on the periodic table. It has a mass of 12. Oxygen has a mass of 16. All right? So if we look right here at the mass of, at the ratio of oxygen to carbon, because oxygen's the heavier one, I'm going to put it first, okay? Right? Then if we have one oxygen, that's 16 grams. And there's only one carbon in this formula, so that's 12 grams. 16 divided by 12 is 1.33 on your calculator, right? Now, if we take a look at carbon dioxide, that's a totally different thing. This is a poison. It will kill you. This is something that you breathe out. So these two molecules are very, very different. No mistaking. But they're made of the same things. Only carbon and only oxygen, right? Let's look at the ratio of masses here. There's 2 oxygens here, so that's going to be 32, and there's still only one carbon. 32 to 12. 32 to 12 gives you 2.66. Now, do you mathematically see something that could happen with these two numbers? They're evenly divisible. Check it out. 2.66 divided by 1.33 gives you an even number, 2. That's the law of multiple proportions. So if you were working in a lab and analyzing different substances, just on their mass alone, and by the proportions of mass of the different atoms, you can prove their relationship with the law of multiple proportions, okay? The proportions of each are evenly divisible into each other. Make sense? All right, so I'm giving you a worksheet, and I'm just going to ask you to try this 3 different times. I'm going to leave this on the board for the people in here, and people at home, just pause your screen, and here's the math for you, okay? This is what you do. It's called the law of multiple proportions.